Okay guys, today we are going to look at equations and we're going to look at how x's can be related to y's, and there's sort of three different things that we're going to look at. We're going to look at direct variation, joint variation, and inverse variation. Okay, and so let's think of a problem, and let's start with, there's going to be three different types. So let's say direct variation. Okay, so let's think of how many students do we have in the class? 8. Okay, how many shoes do we have? 16. How about if we had half as many students, we would have what? Half as many shoes. So what is the relationship between shoes and students? Direct, right? It's very direct, direct variation. And so we would say the number of shoes is equal to what?
2 times the number of students.
2 times the number of students, okay? Shoes is 2 times students. Now, of course, you could argue, well, sometimes Tanner doesn't wear his shoes. No. Tanner always wears his shoes. You know what I mean? You could argue maybe somebody doesn't have shoes. But you know what I'm saying? The number of shoes is directly related to the number of students. Okay? And this is the way the direct variation works. You have some variable y is equal to some constant k times x. Now, if y is k times x, what is, so this is what kind of variation? Direct variation. Okay. Now, which is the independent variable? X. And which is the dependent variable? Y. Because y depends on x. Y depends on x. All right, so let's look at something. Let's say that on average our school spends $203 per student on computer equipment. Okay, so it's $203 per student. Okay, now write me an equation that is a direct variation.
C equals S times 203.
Okay, so what?
C equals S times 203.
C is equal to S times 203. I like the way you're thinking, Braden. But just to make sure everyone understands, what is C?
Cost.
The cost. Okay. And what is S?
Students.
The number of students. Okay. So this is a direct variation. Okay. This is a direct variation. Now, if C is S times 203, what is the independent variable, Kelsey?
S.
S. And Josie, what is the dependent variable?
C.
C. This is easy or hard? Okay, so a direct variation is y is equal to k times x. Okay, so let's look at a problem. Let's say that y varies directly with x. Right off the bat, what does that tell me? What equation am I going to be working with?
Direct variation.
Yeah. Now, if it said indirectly, you would have to use a different one, which I'll show you later. But this is the key word. Y varies directly with x. That means we're going to be doing this. Okay. And then what you know is that I'm going to tell you that y is equal to 12 when x is equal to -3. Okay. And then find y when x is equal to 16. All right, so when I say y varies directly with x, immediately you should be thinking what, Jaden?
Can you say that again?
Okay, if I say y varies directly with x, what should you be thinking?
Direct variation.
Okay, and so I should right off the bat write down what?
Y equals k times x.
Yeah, y is equal to k times x. Okay. Now, Levi, what is it that I'm going to need to figure out here? The what?
The
The what?
dependent.
Okay, we know the dependent is y and the independent is x. So what do
Find K.
I got to find the what?
K.
I got to find the k. I've got to find the k. So Levi, tell me how you would figure out what k is.
You have to divide 12
Well-
by negative 3.
Okay, but you're right. But say it better. You plug in what?
Y. Or negative 12. Or 12.
I plug in the what and the what?
Y and x.
The y and the x. So I say what?
12
12
equals k
k
times negative 3.
times negative 3. Why did I put parentheses around the negative 3?
So it's not K minus.
Yeah, so it's k times negative 3. Use those parentheses. Okay, so Kelsey, k is going to be equal to what?
Negative 3 divided by 12.
Negative 3 divided
What?
by 12? What is k?
The independent.
I know, but tell me how to get k. I want to solve for k. Solving for k means I want to get k how?
By itself.
Okay, how do I get k by itself? I need to do what?
Divide both sides by negative 3.
Okay, so then k is equal to what?
Negative 4.
No, but tell me what over what?
12 over minus 3.
Okay, when you said it a while ago, you said it backwards. Does that make sense? Okay, Jaden, now I know what?
K.
So what should I do before I do anything else? Somebody tell me, Mario, what should I do?
Find y.
Well, no. I just did a bunch of work to find what?
Okay.
So what should I do with that k?
Or plug it in.
Yeah, so now you have to put the k back in. And Josie, what do I get when I put the k back in?
12 equals.
No. I want a general equation where I can calculate any y based on any x. But to do that, I had to find what?
K.
K. So now what do I do with k?
Plug in.
Okay, so what do I write down?
Y equals 12 over negative 3.
Okay, but that's what? Negative 4 times what?
16.
Times x. Yes. Okay. Does that make sense? Okay. Make sure you guys are getting it because it's not just popping in your head. Why did we solve for k? So I could write this equation so it would work for any x. Does that make sense?
Yes, sir.
Mario, why did I solve for k?
So you could solve for
So I could what?
solve for x.
I can't hear you.
So you could solve for any x.
Yeah, I could solve what for any x?
Y.
I could find y for
X.
any x. Okay. So does this make sense? Now, what was the question that it was asking you, Jaden?
To find y when x is 16.
Is that going to be easy or hard?
Easy.
What do I do, Jaden?
You put it into the equation.
What's it?
You put negative 4 and 16 into the equation.
I put what?
You put the x value,
And what is the x value?
16, so the y equals
Y equals
negative 4 times 16.
times 16. And that is going to give me y is equal to minus 64. Okay. In these things, step 1, you have to find the what?
You solve for k.
Yeah, you got to find k. Then you rewrite the equation with that value of k in it. But it's going to be x and y, or it's going to be s and c. It's going to still have that equation, but you put the k in. Now, for any independent variable, you can calculate the what? The dependent variable. Does that make sense? Okay. So, that is an example of what? Direct variation. Okay. Now there's another one. And the other one is indirect. Indirect. variation. In this case, what you have is y is equal to k over x. Okay? So as x gets bigger, y gets what? Smaller. Okay? So if they say indirect variation, that cues you on this, but number one, you find what? So step one, I'm going to find what? K. And then write equation with k. And then 3, find the value of interest. Right? That's like solve the problem, answer the question. But you start, you got to find k, and they'll give you enough information in the problem to find k. Then you write the equation in terms of k, and then you find the value of, the value of interest. All right. So let's say that I say that r varies inversely with t. So r varies inversely with t. Okay. When r equals 18, t is equal to minus 3. And now find r when t equals minus 11. All right. Now, Levi, tell me something that is the first thing that's important here. Like, tell me something. Hold on. Yes?
I have a question.
Uh-huh.
You wrote indirect variation, and then you wrote varies inversely with t.
Okay, yeah, so let's call this inverse. Thank you, that's a better word. Inverse. I put the wrong word there, Logan, and you caught me. Okay, Levi, tell me something. Say something out loud.
R is going to be like y, and t is going to be like k.
Okay, so tell me what I should write. You're right, but tell me what I should write down then.
18 equals...
No. You've got to always start by writing the equation. Okay, so R.
K over negative 3.
No!
Oh, k over t.
Okay, you start by writing the equation. Josie, what's the first thing you do?
First thing, write the equation.
Okay, Jaden, what's the first thing you do?
You write the equation.
What does Levi keep skipping?
The equation.
Writing the equation. Okay, now Levi, what do you do? Now that you wrote the equation, now what do you do?
You can plug in r's and t.
Okay, so now tell me what you want me to write down.
18 equals k over negative 3.
Okay, now Mario, tell me what you want me to do.
Multiply 18 by negative 3.
Right, you're right, that's what we're going to do, but what are we doing? We're finding k. So k is equal to 18 times negative 3. K is equal to, I will help you with that, k is equal to minus 54. Okay, k is minus 54. Now, Braden, tell me what you need to do.
Plug in k to the equation.
Okay, so tell me what to write down. You're right. Tell me what to
R
write down.
equals
R equals?
negative 54 over negative 11.
No.
Or 11, I mean.
No! You guys are not writing the equation down. What did you skip? What did you
The
skip?
equation.
Okay, so R is minus 54 over what?
Negative 11.
No, Braden. What you got to
Over
do?
t.
Over t. Boom. Okay, so about half the... That's okay, Braden. Why is it good that you made that mistake in front of the
I
class?
don't do it again.
Yeah, okay. See, we see what you're missing, right? We see what you're missing. And Levi, you're making the same mistake. You've got to write the equation down generally, and then I solve for what?
K.
K. And then after I solve for K, what do I do, Jaden?
You put it in the equation.
With the R and the T. Okay, now, Kelsey, what can I do now, Kelsey?
You can put the -1 on
Yes, or negative 11, okay.
Oh, sorry, it looks like
That's,
one.
yeah, I know. You knew exactly what to do. You just didn't see this right. Okay. So now I can put R is equal to minus 54 over 11. Okay, and that is your answer. I calculated it. Does that make sense?
Wouldn't it be positive?
It's negative 11.
Oh, did I? Okay, negative 11. Okay, so R is equal to 54 over 11. Very good, Levi. Good catch. Okay, that makes me happy. That shows that you're paying attention. Okay, so you've got to look in the key word of the problem to figure out if you're dealing with a what, or a what.
Direct joiner numbers.
Yeah. So what are you going to ask me to do now? I've shown you two things. What do you need to know how to do now?
Join.
Joint. Okay. Joint. So now we are going to go over here. So this y is k over x, y is kx, and then for joint variation, you're going to have y is equal to k times x times z. Oh, this time, y depends on both what and what? X and z. K is still your constant. All right, does that make sense? So let's say I'm going to tell you y varies jointly with x and z. Y varies jointly with x and z. So if y is equal to 16 and z is equal to 2, then x is equal to 5. Okay? Find y when x is equal to 8 and z is equal to 3. Okay. So Josie, tell me the first thing that I should write down.
The equation.
Which equation?
Y equals k times x times z.
Yeah. Now, why did you use this one instead of this one or this one, Josie?
Because it's jointly.
Yeah. So you see, you picked the key word here, and now I know. I write something down. In Levi, I write y is equal to k times x times z without any numbers in it. Because that's establishing that it's what?
Sure.
Okay, Logan, what would you do now?
You put in the numbers that was given you. So you would say 16.
Okay, 16
K.
k
Times 5 times 2.
times 5 times 2. And you're doing that because you're trying to find what?
K.
K. So what would k be equal to, Kelsey? Yes.
Okay.
I'm trying to get what by itself.
K.
So I need to get rid of the what?
The 5 and the 2.
So how do I get rid of them?
Multiply them.
Multiply them? So if I multiplied both sides by 10, then I would...
I mean, like, multiply them together first.
Okay, so I have 10. Now how do I get rid of the 10?
Divide.
Divide what?
Both sides by 10.
Divide both sides of the...
Of the equation by 10.
Okay. And so I would have k is equal to 16 divided by 10. All right. Now, Braden, tell me what I should write down now.
8 over.
K equals 6 over 5.
Okay.
Or not 6,
K-
8 over 5.
8 over 5. Reduce your fractions. Good. Now, Braden, tell me what I should write down.
The equation.
Tell me what to write down.
Y equals x times z times 8 over 5.
Okay. Why am I so happy with what Braden said?
Plug in
Because
z.
you remember that
Because he remembered to put the x and the y and the z in and not just plug numbers in. Now, Levi, what can I do now?
Y
Now that I have this, I say y is equal to what?
8 over 5 times
8 over 5 times 8 times 3. Does that make sense? Yeah, once I write this down, now I can go put the numbers in. Okay, and 8 times 3 is, let's see, what does this come out to? 8 times 3 is 24, and 24 times 8 over 5, y is equal to 38.4. Does that look good? Does this make sense? Okay, this is easy. Just don't skip your steps. This is easy, just don't skip your steps. This is chapter 8, section 4. Chapter 8, section 4. We're going to do 8 through 12, 54, 56, 58, and the bonus is 52.